A very good morning, good afternoon, and good evening to all. So this is Suvendu Sir, your physics mentor, and welcome to my YouTube channel. So in today's class, we will solve class 10 science CBSE sample paper section C physics questions. Okay. So in our previous class, we have discussed about section A and B physics questions. So in section C, our first question is question number 31. What is the fundamental difference between hypermetropia and myopia in terms of the optical experience of a person? Okay. So what you have to write? So first thing is myopia. Remember, myopia otherwise termed as short-sightedness. So in case of myopia, you remember a person can see nearby objects clearly but cannot see far off objects. And another defect is hypermetropia. It is otherwise termed as far-sightedness or long-sightedness. So, in this defect of vision, a person can see far off objects clearly but unable to see nearby objects clearly. Okay. So this is about our bit A question. Next question is, the diagram below shows a special case of an eye defect. So what is the defect that is shown in the figure? Okay. So look at this figure. As per this figure, this point represents our image. And in this figure, image is formed behind the retina. That means this defect is our hypermetropia. So this is the answer of bit A, and in bit B, our first bit question, as image is formed behind the retina, so defect is hypermetropia. Okay. In second bit, it is asking state one cause for such a defect. Okay. So what are the causes of hypermetropia? You may write only one case. So it is arising due to, so it arises due to decrease in length of eyeball, or you may write it arises due to flat nature of cornea, or you may write due to increase in focal length of eye lens. Okay. As per the question, you have to write any one out of these three. Okay. So last question is, explain with the reason if a concave lens can be used to correct the defect. Okay. So as per the third bit, what is the characteristics of concave lens? First you see. Concave lens. Concave lens diverge the light rays coming towards the eyeball. Okay, so a convex lens should be used with which will help to converge the light rays, because convex lens is known as converging lens, converge the light rays so as to obtain the image on retina. Okay, so with this we have completed our question number 31. I hope it is clear to all of you. Next, come to another question is there for visually impaired student. You see, it is given what is the fundamental difference between hypermetropia and myopia in terms of the optical experience of a person. Already we have discussed in the above question. And what are the causes of myopia in the human eye? Okay, that means you have to write these are the causes of hypermetropia. Okay, so what are the causes of myopia? First bit question already we have discussed. For bit B, you have to mention the causes of myopia. So myopia arises due to increase in length of eyeball, excessive curvature in cornea, due to decrease in focal length of eye lens, okay, so finished. Next question is, state the relationship between the resistance R of a wire to its length L and cross-sectional area A, and it is given use the mathematical symbols to arrive at the final formula. Okay, it is a very simple question. So as for the question number 32, we know R resistance of a conductor is directly proportional to length of the conductor when area of cross section is constant, and also R proportional to 1 by A when L is equal to constant. Okay, so combining we can write R proportional to L by A, which implies R is equals to constant into L by A, and this constant is termed as your rho. So R is equals to rho into L by A. So what is rho? In this case, rho is proportionality constant called resistivity of the material. Resistivity of material. Okay, and it is asking use the formula to define the resistivity of a material. Okay, so how to define the resistivity of a material? So answer of bit B, we know R is equals to rho L by A. So you put one in condition when area of cross section is equal to 1 unit square and L is equals to 1 unit, then you will get rho is equals to R. Yes. So in order to define resistivity, if R is equal to rho L by A, so rho is equal to R A by L. Now you put A is equal to 1 unit square and L equal to 1 unit, then you will get rho equal to R. So only you have to define all these things in a sentence. So what you have to write? So simply you have to write resistivity is numerically equal to resistance of a conducting wire. But the condition is conducting wire of unit length and unit cross sectional area. Okay. So in this way you have to write the answer of question number 32. Next come to question number 33. Yes, it is a very good question. Now see, it is given Mona was doing an experiment with magnetic compass and a straight current carrying wire. Okay, she observed that as she moved the compass away from the current carrying wire, the deflection of the compass needle reduced. Yes. So explain why the deflection of compass needle reduced as Mona moved away the compass needle from the current carrying wire. So for bit A, what you have to write? So its answer is, we know magnetic field strength or strength of magnetic field is inversely proportional to R. So what you have to write in language? B means strength of magnetic field and what is R in this case? R is the distance of point of observation from the current carrying wire. So we know strength of magnetic field is inversely proportional to distance from current carrying wire. Okay. So from this expression we can think, when thus if R increases, then what will happen to B? Then B decreases. Okay. And due to decrease in the strength of magnetic field, which implies deflection is less. It is actually a conceptual question. Okay. Next come to second bit. Mention one thing that could have changed in the circuit of the wire that could increase the deflection of the needle. So what we have to do in order to increase the deflection of the needle? The simplest answer you have to write for bit B. You have to mention, we know strength of magnetic field is directly proportional to the current through the wire. B proportional to B is directly proportional to I. So when current in the wire increases, then what will happen? Then strength of magnetic field also increases. Okay. So this is about your bit B question. Next in bit C, it is given or it is asking, explain with reason that what will be the direction of the magnetic field associated with the wire for the case described by the above figure. Okay. So you have to judge the direction of magnetic field. Now see this figure properly. So in this figure, it represents your big bar, that means positive terminal. This is negative terminal. So what is the direction of current? Conventional direction of current is from positive to negative terminal. So this is the direction of current in the wire. Okay. So if you will observe, you can see the direction of current in the wire is downward direction. So in order to determine the direction of magnetic field, which rule we have to use? Right hand thumb rule. Okay. Right hand thumb rule. So now see this. So if you will apply right hand thumb rule when current is in downward direction, and the direction of magnetic field is in clockwise direction. Okay. So for bit C, as per right hand thumb rule or Maxwell's right hand thumb rule, as direction of current is downward, so direction of magnetic field is clockwise, is in clockwise sense. Okay, yes. Next, there is a question for visually impaired student. In bit A, it is asking, explain why the deflection of compass needle reduced as Mona moved away from the compass needle from the current carrying wire. Already we have explained in the previous question. Second bit is asking, mention one thing that could have changed in the circuit of the wire that could increase the deflection of the needle. We have to increase the current. Then in bit C, explain with the region how the direction of magnetic field associated with the wire changes if polarity of battery reversed. So simply for bit C we can discuss, if the polarity of battery is reversed, then what will happen? Then direction of current gets reversed. Okay, if when polarity gets reversed, then direction of current also reversed, which implies direction of magnetic field also reversed. Gets reversed. Okay, I hope it is clear to all of you. Yes, so this is all about for today's class. In next class we will discuss the physics questions available in CBSE official sample paper 2024-25 section D, in part section D. So thank you, have a nice day.